So we're going to write quadratic equations. So let's review the forms of the quadratic equations. This is guided notes. So on your piece of paper, I want you to write this down. Standard form is y equals ax squared plus bx plus c. Vertex form, or wait a second, let's talk about standard form a little bit. C is your constant. Typically that's your y-intercept, because when you plug a 0 in, you're just left with the c. We talked about that. Vertex form is when you have a times the quantity x minus h squared plus k. And let's actually write down that the vertex is the opposite of h, but k keeps its sign. Intercept form. Intercept form is y equals a times the quantity x minus p times the quantity x minus q, where p and q are x-intercepts. First example, in your guided notes, you're missing the points. So write the quadratic equation of a parabola containing a vertex of -1, 2 and a point 2, -4. When you're given the vertex, use vertex form of the equation. So vertex form, but we need numbers in these places. So this is hk, so -1 goes in the h position, 2 goes in the k position. So yeah, we can clean this up to be x plus 1 quantity squared. And then we got to figure out, well, wait a second, we need a number for this a position. We're going to use this point, 2, -4, to figure out what this leading coefficient is. But 2, -4 is a point, just like I just said. We're going to plug it in to x and y to figure out what the leading coefficient would be. If this is a point on the parabola, it should make that equation true. So let's figure out A. Plug in 2, -4 into the x and the y coordinate. So when I find A, I use that point, plug their coordinates in, and then use order of operations, solving techniques to figure out what A is. So the last step is to write the equation using the leading coefficient that we found. And don't forget that we already used our vertex in this form. So if I'm given the vertex in the beginning, I should use vertex form. I use the other point to figure out that leading coefficient. Once I find that leading coefficient, I write the equation. Notice how we have a y equals, notice how we have an x still in the problem. This is the equation of a parabola with the vertex at -1, 2 and contains the point 2, -4. So x-intercepts at 3, -1 and a point at 2, -4 again. So write the quadratic equation of a parabola containing the x-intercepts of 3, -1 and a point 2, -4. And this is... So wait a second, I'm eventually going to have a number for the leading coefficient and then both intercepts for the position of P and Q. So wait a second, when I'm given 3, -1, this is our P and our Q. After we clean it up, I still need a number for this leading coefficient. So you use the rest of your information. Use this point to find A. Follow your order of operations and then check to see if we end up with the same A. So using the A and our P and Q from before, we now have an equation of a parabola where the x-intercepts are 3 and -1 and 2, -4 makes this statement true. 2, -4 would be one of your points in your t-chart. So now let's contain the points 0, 5, 1, -1, and 3, 4. Because we're not given the vertex, because we're not given any x-intercepts, we are going to use standard form. But the way we can... Okay, so hold on. Standard form. We need numbers in the place of A, in the place of B, and in the place of C. Plug in 0, 5 into this equation and we'll see what spits out. We'll plug 1, -1 into the equation and we'll see what comes out. We'll plug in 3, 4 into this standard form and see what comes out. So we plug in 0, and yeah, so 0 squared times A is 0, plus B times 0, this also becomes 0, and then we're just left with C. So when we go to the next point, we're going to, instead of have plus C at the end, we're going to put a plus 5 now that we know. Again, you plug in your point. Notice how I put the plus 5 there at the end? So from plugging in this point, 1, -1, we get an equation of -6 equals the leading coefficient plus the linear coefficient. We now need to plug in our third point. So from this point, we use our third. But when we plug it in, let's keep in mind that C was 5. One last time. I'm plugging in the point 3, 4, and I make sure my C is also being used, and I clean it up. We've got 2 equations that we developed, and yes, we're going to have to use elimination. So let's stack them on top of each other and figure out what am I going to have to multiply by to eliminate a variable. So after we multiply the top equation by -3, and we go through a process, we will now have, let's use this equation to plug in 17/6. So we get -53/6. Yes, this is gross. Yes, this 17/6 is gross. 5 was not so gross. But what was the point? Write the quadratic equation of a parabola containing these 3 points. We need this equation where the A is substituted, the B is substituted, and the C is substituted. Quadratic equation containing these 3 points.